No audio? What? Let's try that again. Thanks for the info, chat. I get it. Okay, we have audio now. So today we are doing some 3D scanning. We are trying out the Shining 3D Einscan-SE and the Einscan-SP. These are both structured light scanners, so you can see like the 3 holes up here. There's one, basically a small LED projector and then 2 cameras out to the sides. They come with a rotating table, so it's not like those laser scanners you've seen with, for example, the MakerBot digitizer. That's a completely different class of scanners. The digitizer is just a small webcam and a laser line scanner. These actually are using the professional, well, it is the professional approach of using a projected light pattern onto your scan part. And then have stereo cameras off to the side that pick up that pattern. So it's yeah, it's a much better approach than just the laser line scanners. This one, the SE, the simple one, sells for around $1,200. This one sells for around $2,400 or $2,500. I did play around with them a bit. I gotta say, I am impressed. Just the entire thing. It works really well. If you use the laser line scanners before, this is nothing that you can compare it against. So yeah, let's dive right in. It's going to be interesting how well it works on the laptop, how well it works live. Part-time Ronan is asking, can I keep this? I actually don't know if I can keep this. We should have 2 folks from Shining 3D, the guys who make these scanners, with us in chat. Maybe you guys want to say hello, but maybe they will let me know. All right. So, also, by the way, thanks to all the mods who are here, who are doing their job in chat. Very much appreciated. Right, let's dive right in. I did fix the hotkeys so I can use those. I also kind of changed up the colors on the overhead camera, so that should be better. It feels like that has more delay now, but. Right, MSRP again, $2,500 for this one and $1,200 for the simpler one. They are both, they have the exact same form factor, but the SP you get with an extra tripod, and the SE you don't get with that. But feature-wise, they do the same things. This one has This one has better resolution, so they are claiming 50 micron accuracy for the SP and 100 micron accuracy for the SE. And the cool thing is you can use them in 2 different ways. So what's included here is a turntable right here. So this spins, this is controlled by the scanner. You put your stuff on the table, and it does its thing. But you can also prop this thing up on the tripod for the SP. That's included. For for the SE you have to use a separate one. You plop it on a tripod and you give it a few different perspectives on what you want to scan. So I will scan my car's dashboard with this and make a well-fitting phone holder insert with them. That's like my first plan. So that's what you can also use it for. So you prop it on a tripod, you point it at what you want to scan. It does one scan, it gives you one part of the point cloud. You can move it around if you want to, and then it adds that onto the scan. So that is the second mode you can use it in. And they both scan 200 millimeter cubes apparently on the built-in scanner, or on the built-in rotating table. And the SE does 700 millimeters. That's about that large, a 700 millimeter cube. If you put it on the tripod and scan stuff freestanding, that does 700 millimeters. This one does 1200 millimeters. So 1 meter and 20 centimeters. That is 4 foot. A 4-foot cube fits in the freestanding scan area of this thing. So. Right, let's see. So this is the scanner itself. There we go. That is, the entire hardware. So we can see that the 2 cameras out the sides and the small projector in the center. This is a small LED projector, I believe. So that just projects a light pattern onto your part, and then these two cameras on the sides pick it up. We have a power button on the back. We have a USB port. This is the one you use to connect to your computer, which is not exactly the proper USB connector to use, and a mini USB that actually connects to the turntable. So turntable is controlled by the scanner, and then of course power. Does it scan the top of objects too? Yes, it does. So if you use it on a tripod, if you use it and move it around manually, then of course you can position it either way you want. You can move it around. It will merge those scans by itself. And if you use it on the rotating table, you can actually plop your stuff on there. And as long as it stays in one position during a scan, that's going to pick up. But once one round of scanning is done, you can move your part around and it will match those scans. So yeah, the SP also includes a few scan targets. Well, a few is, there's probably 3,000 or 4,000 of these target stickers. Why are you not, what? There should be video here. Okay, I'm just gonna have to restart this one real quick. A side, deactivate, activate. Okay, so you get these little scanner targets. You literally just stick them onto your objects, onto your scanned objects, and they will give the scanner some reference points to orient itself to. So these come with the SP, and I believe the SE, the cheaper one, does not have the feature to use the targets. But, well, if a scan should not get oriented correctly, you can always align it manually. We'll see if we have to do that today. Yeah, by the way, CNC, no CNC today. Yeah. Machine was fine. I just, stuff boiled over yesterday. Just nah. Right. That's that. Don't ask about it anymore. We're doing 3D scanning today. Okay, so power, USB, and USB. So roughly speaking, what this setup is going to look like is you have your base. It's just a plastic injection molded base with a few rubber feet. An alignment notch right there for the turntable to sit on, which is this guy. This might have been a demo model. It does have a few nicks and scratches, but it should not affect performance. That just seats in right there, and this guy turns. Again, that is controlled by itself. Let's see. People are writing me on Hangouts. So that goes here, and then you have the scanner itself. By default, it doesn't have any way to mount it to anything. So it doesn't have any threads, it's just this box. So you get this bracket that you clip it into, just like that. Maybe centered, there we go. And there's a fan outlet in the back that's going to cool the projector. And now you get your tripod thread. And that just screws into... Yep. Come on, that just screws into this holder right here. Or if you want to use it with a tripod, that's where you're going to attach your tripod. Quick change, quick release plate to, or there you go. Your tripod quick release changer, or screw the tripod onto, and then you have it on there. But for now, we're just going to attach it to this base. By the way, if you're wondering is this too wobbly, no, it is not. You're not going to be touching the scanner during scanning. What about Xbox One Kinect DIY scanner? So this is a different but similar approach. I believe the Kinect also has some sort of structured light, but it has a structured light approach that is in the infrared spectrum, so you don't visibly see it. This actually shines out a white LED projection onto your part. And then it has two black and white cameras on the side. So by default, it does not capture color. if you don't want overhead camera. What do you mean the camera is too hot? I know it is a bit too bright. So by default, it only captures a black and white scan, but what they can actually do, because you know, like the cameras are only black and white, but what it can actually do is this is still a full color projector. So it will just project out a red glow onto your part, then a blue, then a green one, and so on. And these cameras will pick up the color pattern from that. So that is what you can do with that. So I'm not too interested in the color scanning. There is a white balance, so ambient light, etc., shouldn't like influence it too much. But you can do color scanning if you want to. For 3D printing, I don't care about color too much. Okay, tripod. Let's have a quick look inside here. What you get? There's something bouncing around. Oops. Right, Shining 3D, just a quick sticker on there. How does this fold up? Okay, so this folds up all the way. Here we go. And that is just a... feels solid, certainly feels... this probably needs to click in. There we go. Feels solid enough, and you get a hex key 4. I assume that's for the quick release plate. If it will come out, we have... There you go. That's actually the standard Arca Swiss quick release that I use on my cameras as well. So these... There you go. And this one comes down. Okay, standard photography tripod. So that's what you can mount the scanner to as well if you want to. If you want to do that handheld, it's not handheld, but if you want to do that freestanding scanning. Okay. So again, that is included with the SP. The SE does not include that. But let's see. So assembly setup, basically 2 USB cords and a power supply. This one does come with a European power cord, which is good. So you get this not quite to spec USB cord. A USB-A to USB-A cord, which I don't think that is in the USB specs. But that's what you connect to the scanner, and the other side hooks up to your computer. I'm just going to use this side right there. Is this the scanner that projects the laser grid? Yes, it is. It's technically not a laser grid, but it's still a projection onto your scanned part. And I do have a few different scanning parts here. I did play around and try to scan the camera, or one of my cameras, which is black and shiny, and just basically a worst case example. And that didn't turn out too great, like all these shiny parts didn't pick up. So today I want to keep it nice and easy, and I have a few parts. I have this guy. If you've seen any of my 3D scanner videos before, that is my standard 3D scan test object that I use. I've used that in the AIO's Zeus review. I've used that in, pretty much all of my 3D scanning tries yet. I have a snail housing that's hollow on the inside, so that's going to be interesting how that gets picked up. I have this larger figurine. I already addressed the end of yesterday's stream, so stop asking about it. I might blacklist some stuff otherwise. So I have this one to scan. This is just at the edge of what fits on the table here, so it's going to be interesting to see how that picks up. And I've brought this plastic part, which is a thin injection molded cover actually from the IKEA kitchens. Those cover up like the wall mounting brackets inside the cabinets. So that's going to be interesting how that picks up. Again, white, somewhat translucent, not much features for the software to align things to. So that's going to be probably one of the more challenging ones. All right, so this table plugs into the USB cord right there. Feels good. And then the other end plugs into the scanner right here. The bracket needs to move slightly. There you go. And that plugs in. Okay. And that should be good. So one feature you can see on this table that the Einscan-SE does not have are these markers on the bed. So these are groups of 5 unique markers. So each of these groups is different. And the software is going to pick up these patterns on the bed if you wanted to use that to align your scans. By default, it will rely on accurate rotation of the bed. So you put something on here, the software or the scanner will rotate it by a set degree and it will assume that rotation is correct. But you can also say, okay, I want to realign every single scan to these dots. So that is what the SP does. The SE does not do that. I don't think this is something I'm going to be using all that much. So yeah, just wait and see, guys. This is, from what I've seen, the scan quality is really good. So if you're saying after 5 scan cycles, you're not going to end up with much, I would doubt that. Of course, you're going to introduce some noise. You're going to introduce a bit of like random error because this doesn't have infinite resolution. But I think 5 cycles shouldn't make that much of a difference. I think the 3D printing part is probably the bigger culprit here. We will try to do that today. I did bring one of my Mark IIs. Does that fit in here? No. I did bring one of my Mark IIs, so we can try out how a print is gonna look. And I think I'm just gonna print that the cherub, this guy. That's going to be the first thing we scan, and I will try to scale it down and print it within like an hour or so, or even faster. So that is going to be interesting. Will I try a free scan today? I will not, because I don't really have anything. Oh, serial number. Am I supposed to show that? I don't know. Too late. I will not try that today because I don't really have anything that I could scan in here freestanding. I'll stick to the rotating table right now, less variables. Again, how do you pronounce that? But yeah, that's what we're gonna do today. So, oh yeah, we could scan the 1,000,000 views hairy lion. Congrats, Joel, by the way. First video with 1,000,000 views, and the second one is chasing straight after. So, software. Now, this is assembled. That's it. We're gonna need power. Well, okay, I already gave it power. We can turn it on, and scan my glasses. They're transparent. They're not going to scan. Yeah, let's check out the software. So, from what I've read up on this machine, the software seems to be the weakest part.
Excellent channel. I learned a lot from you. Thank you.
Something's talking. Yeah, software seems to be the weakest part, but I've used it. It's fine. Thanks for the tip. Excellent channel. Much appreciated. Right. Software. So software download. The software is a bit finicky about activation. So it does always need the scanner connected to the computer to run at all. So if you scan something, you can't just, take your laptop and process the scan data afterwards. You actually need to do it right away with the scanner still connected. So that is one limitation, and activation is kind of finicky. Usually it does it online through like the serial number of the printer, etc. But there's also a PDF file, a backup file that you can use for that. So let's jump into that. So there's that. So usually you go to the Shining 3D download Einscan-S series, you get your software download. There's always, or it feels like there's always a beta version you can scan or you can download. You can scan the beta version. Yeah, it feels like there's always some sort of beta version you can try out. The folks told me it's better, but the current one is fine, so we are going to stick to this one. So let's see, Einscan, there's the PLE files that I downloaded. So Einscan-S series, let's install this. Oh, cool, that did not kill the screen cap. Yeah, the questions on how do you make sure the scanner is well connected to the computer. So we do actually have to turn it on first, and that is just the power button back here. I think I have to hold this. Do I? No, okay. It's on, and you might be able to hear the fan. It does slightly, yeah. There are some vibrations. I can feel the table vibrating, but it's not excessively noisy. So make sure the scanner is well connected. So yes, install Scan Wizard. Next we are, yeah, United States, simplified English. We have a Einscan-SP connected. Let's see if the online activation works. Device is not connected. Oh yeah, I do actually have to plug in the other side. Ha! So there's a spare USB port. So let's try that again. Online activation. My laptop's webcam just lit up. So activated file did not match, so we can do local activation and just pick the Einscan-SP PLE file. Import successful, and now the install will go on. Is this the first time to use Einscan? Actually get this in the background here. So I've been told if I hit no, it's going to give me a lengthy survey, so we're just going to say yes, so it's not going to ask us how our past experiences were. Take survey. Nope. Next. Yes, okay, that was the correct path to navigate that. I accept whatever. Yeah, click install. Let's do that. FTDI drivers. Let's install those as well. It's a German scanner. No, it is not. It is a Chinese brand. As you might, you know, if you look through the software and just the entire feel to it, it screams Far East. The hardware actually feels quite nice. The hardware is repair. Whatever else. Let's repair this. I already have the Visual C++ stuff installed, but let's just repair install these to make sure we have the right ones. So the hardware feels, I mean, it's not like milled aluminum or anything. It is solid injection molded plastic. Like there is a bit of slop in a few parts, but it's fine. It is okay. It's not cheap hardware, and it's not. I mean, it is not. The camera just flashed, or was it the screen? It's not cheap hardware, but it's also not like the super most premium. Again, it is a mid-priced scanner. The SP is 2500 roughly. The SE, same looks, similar feature set, slightly smaller, freestanding, so tripod scan mode area, and slightly worse resolution and slower speed. So yeah, that is 1200. So overall decent, good enough. So you're not throwing out money for like over-engineered stuff. This feels good. 7K? No, it is 1200. You're probably looking J for CK. You're probably looking at the wrong one. These are the Einscan-SE and SPs. This is not the Einscan Pro. So yeah, don't confuse them. They have a few different they have a few different models. So they have the Einscan-S, which I believe is the older version, then the SP, the premium newer version, the SE, the standard newer version, and then there's the Einscan Pro. That's probably the one you're referring to with 7K. That does like the handheld paint gun or airbrush style scanning. These do not do that. So you can't just take the scanner and just wave it up and down. You do have to put it on a tripod, leave it in position for a bit, and then it does the scanning. It does one cycle. Restart computer right now. Nope, I do not want to do this. So yeah, this is a bit slower than the Pro, but it still does, you know, similar things. So for example, someone was asking about scanning a face. Yes, you can definitely do that. Again, it aligns individual scans, so as long as like your mimic, yeah, your facial gestures don't change, you can just move the scanner around, or you could even probably rotate the person you're scanning on a swivel chair or something. So, right. Software we have, yes. Einscan-S. So software loading up on the wrong screen. And hold on. There we go. How large can I pull this? Probably around there. Okay, we have the Einscan-SP with the dyno on there. We have that loaded up. Selected next. And it does activate my laptop's webcam. That is... that might not be perfect. So let's see. Yes, that looks good. So we are doing an auto scan with turntable. So fixed scan, again, that's on the tripod. Auto scan, that is the setup we have right here with the spinny table and the scanner. So next, calibration data unavailable. Okay, please calibrate scanner. So let's try that. Let's see how well this works in this, I mean, relatively brightly lit situation. So yeah, these are registration marks on the table. And there's one hotkey that doesn't work, and that's this one. Registration marks that the scanner can use to notice which direction this table is turned. The other one doesn't have it, and it's not using them by default. So let's see. So we are getting the view from the stereo camera. So that's the left camera right there. Hello. And that's, well, left or right. Always kind of hard which way you're looking at. So two cameras, they're working. And if you look at the, you might see it on camera, maybe not. But that is the projected light from the small projector in the lower, well, right there. And it has this cross in the center. I don't know, if I move my hands real fast, you might be able to see the DLP rainbow effect. Probably not. Okay, so place the calibration board, this guy, onto the platform. So that's what we're going to do. It has this little plastic holder. And we're aligning it with the 3 dots facing down. And I was told to not have this cross. Can you see that? Wow, you actually cannot see that. Sort of. You can sort of make out this cross right there. Yeah, to not have that cover any dots. So that should be good. Request quotes, Hogger the. So if you want to know how much these cost for you, there are Amazon links in the video description for both the SP, which this model is, and the SE. So just click that and you're gonna see how much it costs for you. It's around $1,200 for the cheaper one and $2,500 for the more expensive one. So we are snapping. or scanning, calibrating. So it's moving the platform tiny bits at a time, then it moves it around all the way. And just everything that's red on screen that is overexposed apparently. And yeah, it's, whoops, I probably shouldn't put my hand in there. Right, so we're still lit up from the scanner, and that just yeah, for now I think that is just a static white light we're getting. So we rotate this thing. The SP has this nice thick aluminum plate that is included. The SE has a lighter duty foam core one instead. So that is correct. All right, so that is the second calibration pass done. We're going to do another one, so this base shouldn't move too much. I think it kind of auto lines a bit as well, but better safe than sorry. Why is part-time Ronin blue? Because he is a, or he or she, never assume genders, is a mod who has special permissions on the channel as a regular viewer and regular chat attendee. Yeah, so Laurencio Marin is bringing up a good point, and that is dimensional calibrating. Okay, so it's just calculating in the background right now. Brought up a good point, which is dimensional accuracy, which is something laser line scanners struggle with immensely, and stuff like Kinect also struggles with quite a bit. So I've had laser line scans that were just, you know, warped and too skinny, and it didn't look good. This thing apparently, or supposedly, is dimensionally accurate. So the scanner knows which distance stuff is from it because it has the stereo cameras. We just calibrated scale apparently, and whatever you put on a table or whatever you scan in the freestanding mode should come out fairly accurately. So I think it is within 1% or so, or better. So this thing has a 50 micron resolution, which I think is pretty good, but it's gonna, I'll have to test out how well like a fixed dimension comes out in the scans. But you can definitely just plop something like this into your CAD tool or NetFab or wherever and use it to take reference dimensions of parts, or use the surface or the 3D model for an actual model as a 3D print or as a CAD input. So, Einscan-SP, what is this? Chirburp. Scan 1, let's try that. Okay, so we are doing so we could do the texture scan, we could add the colored scan to this, or we can do the non-texture scan, which is faster, so we're going to use that. So calibration card comes off. Yeah, 50 microns sounds pretty decent. That is just the density of the point cloud, so it has a 50 micron resolution. And it does have that 50 micron resolution, trust me. We're going to take a look at all these details in the bottom here. So before we actually start the scan, let me just give you a close-up view of the details on this model. So we have quite a bit, you can see the DLP flickering right there. So that's the center cross. So we have quite a bit of texture and details here. So this ball on the bottom here is textured. So if you're going to see that in the scan, that is from the actual model itself. Up here the body is smooth. Then the feathers in the back, they have some very intricate details. I'm just leaving my fingers in here for scale. And then there is some nice undercut here near the shoulders. That's going to be interesting how we get in there. And then again, sides are smooth. Fingers are sort of tiny. They're like 1 millimeter each. And yeah, there is some nice texture down here as well. So that's really going to be interesting how well it picks up the texture on this bottom ball and how smooth these skin surfaces stay. I'm going to 3D print a scan in the end. Yes, that is going to be the very first thing I do, actually. So we can select the brightness here. So we have a bright to dark slider, and everything that's red is overexposed. So we want to have as little red as possible. So bright white, white objects obviously scan the best because you know that the scanner is going to have the most contrast on the part. And dark difficult to scan is the worst mode. And it also has an HDR mode if you need to use that. So turntable steps, that is like your base setting. Turntable steps, so it's going to do 8 scans, 8 stereo scans. Try saying that real fast. So that HD... what we're doing right now is we have 2 cameras, so we have basically 2 point clouds from each scanning position. It's going to do 8 positions. So 1, it's going to rotate by 45 degrees, move on, and then assemble all those scans into 1. So let's just try with 8 positions. We can always add more scans to this. So if we only do a single scan with 8 positions right now, we can slightly rotate it or set it to 16 and just scan again. So let's just start the scan right here. Now it is relatively bright in here. There we go. There's our scan. It is relatively bright in here, but it looks like the projector actually has enough brightness to work over that.
By to 0 liters. It's lychee and guava Berliner Weiss tongues.
Pixel Speeches is failing there. Today's beer suggestion, Mr. Pink by 2. Oh well, it's lychee and guava Berliner Weiss. So that sounds like fun. Thanks for the tip, Mickey Man. So yeah, I think you can see that quite well. And yeah, there is our first 3D model. So as you can see that there are still a few gaps in here, and if we zoom in, we can see the actual point cloud, because right now it is not a solid model yet. But it actually looks like it picked up the smooth surface on the skin fairly well. It's actually, it has scanned the fingers, and the texture down here is being picked up pretty nicely. So again, that is our original part. You can actually move this around. Just my hand for a scale. This is like 4 inches, 10 centimeters tall. So this is what the very first scan looks like. So now what we can do, of course, the bottom didn't scan. The bottom here didn't scan. The inside doesn't have anything in here yet. And like these undercuts under the wings don't have anything either. So what we can do is we can actually just take this part and lay it flat, as long as it doesn't roll around, maybe with the wings on the back. And there's your part number if you want to buy one of those on eBay. Where's Philoween? Yes, I'm getting there. I actually have 2 they're being worked on right now. So we can actually just lay it flat like that. And that looks good. Let's hit OK, and let's just scan again. And that is just going to run the full scan cycle again and hopefully align it automatically. There you can see the structured light process. It's just repeating patterns that the scanner knows where to look for. So yeah. That's why Kinect is not even mentioned the details. Yeah, the resolution on this thing is pretty good from what I'm seeing. Right, so the SP scans a lot faster than the SE. It's twice as fast. I think this is 4 seconds per scan. Maybe somewhere it's twice as fast. And the SP scans twice as fast as the SE. So I'm thinking it just has a better sensor, a faster sensor in there. So there is our second scan. All right. Good details again. Obviously the backside didn't get anything because that is laying flat against the bed. So let's hit OK. Now it's auto aligning the first scan to the second one. And there we go. That is, you can see that the bottom is in here. You can even see, look at that, you can even see where the sticker is protruding ever so slightly. And that is actually the merged file from the first to the second scan. So yeah, there's a bit of a line back here. I think that's just where the second scan is starting. So this has automatically been aligned and merged into a single point cloud. So let's just try another perspective. How can we get this thing stable? So of course, if it rolls around during a scan, then that scan is not going to be any good. But maybe that can be another stable position. So we could, that's how we had it before. That's the first scan. So yeah, this side looks like it's not going to roll around. So let's just add another scan to this and go. Clay to hold it. Yes. Some putty, some Play-Doh even, that's what's recommended to hold it in place. I actually don't have any Play-Doh, but I do have some plumber's putty, so I might try and use that if you want to add more perspectives. What I might also try is just to add a 16 position scan to this, just if you want to get like the back sides of the wings, etc. The undercut's going. Oh, that looks like there's something misaligned. Okay, aligned it, auto aligned it. So that's good. So even though during scanning the base looked like it was falling apart, it actually corrected for that and pulled itself together. So live preview is a cool feature. Yes, it is. It definitely is. And that is another bit done. So it looks like we're getting really good coverage even in here in the shoulders. So these small holes right here, these are going to get patched up. Like I'd say the base is really good. The base is done at this point. So what we need is like this area right here. That is going to be a very rough patch. How do we, so that's Control and left, no, Alt and left, no, Shift and left, nope, that's select. So you can select and edit some stuff right there. So deselect. Still trying to find the button for move. There is none. Okay, but yeah, like this area right here, I do want to slightly patch up, and it looks like if we even just scan it like this, it should fill in. So let's just try one more standing up, and let's do that with 16 steps. So we can up to 100. We can do up to 180 steps, which is, yeah, quite a few. Or let's do 20. So let's hit it again and just get the. I'm just trying to get the small parts under the right arm filled in, and yeah, it's looking like it's picking that up pretty well. Of course, that is darker. Maybe next scan is going to pick up more of this region right here. Middle mouse button. Middle mouse button doesn't do anything for me, but that might just be the Logitech mouse being set up somewhat miscorrectly. 45 degrees scan. Yeah, I will need to get something to hold that in position. So, right. Plus coded targets. We're not going to need that. I will grab some plumber's putty while that scans. Because again, I don't have any Play-Doh. So be right back. Hold tight. Let's unplug this real quick so you get some audio. Scan speed on this thing, especially for what you get per scan. Let me plug this back in. Here we go. So scan speed, I'm pretty happy with. Yeah, this looks like it picked up a few more details. Scan speed is pretty good. Again, on the SE, you're only going to get half that speed. It's going to take exactly twice as long. Ooh, that looks like it's... that doesn't look really fluid anymore, but yeah. The SE is half that speed, 4 seconds per scan, yeah. Not NVIDIA limited anymore. Okay, so what is this? Why are we getting two colors now? Okay, there's a darker and a lighter blue, but it looks like we got most of the important bits. I mean, I'm sure I could get like in here somehow, like with a perspective like this. I do have the putty here. But let's just try what happens when we actually export this thing. It's this one, mesh, yes. So we want to do for 3D printing for, well, why are they using a 2D printer here? If you want to do 3D printing, we're going to use the watertight mesh. That's what your slices are going to want. If you just want to import it into a CAD tool to get a reference surface, etc., you can probably go with the unwatertight mesh, because that is going to be the exact geometry that was scanned, and this one will patch holes and will add some geometry that was not there originally. I'm actually going to go with, let's see, medium detail. So yeah. And that's just going to process. So CPU, I mean, OBS soaks up a lot. Einscan, it will use whatever CPU it gets. So yeah, please excuse that the stream may be skipping a bit right now, but I'm just gonna let that process. So question from chat, glossy objects, yes. So the glossy objects that I tried to scan again was just a camera plus lens. I think I even have the very lens. No, I don't. But basically, let's just use the old camera. Basically something like this, where it's a matte black body and then a lens with some glass and some shiny metal on the outside. That is kind of a bad example or bad thing to scan. So with the screen, if that's flipped out, you can see how glossy that is. But the there we go. But like this shiny surface like this, that does not scan well. Also lenses, glossy stuff, that also doesn't pick up particularly well. Then more shiny stuff up here doesn't work well. And black in general does not like to scan well. So if you have the option, what you do is, video is getting laggy, I know. If you have the option, what you should do or can do is take I think it's a chalk spray sort of thing. that you can spray onto these parts. It basically, once it dries, it creates like a dust, a very matte white dust coating on your part. I mean, with a lens, you probably wouldn't want to spray that on there, but that is a temporary coating for glossy stuff like this, or what is like starch, etc. You can just lightly dust that on it, and you yeah, you get a much better scan result. Like this thing had holes, like it was, you know, like it was a fishing net. So again, glossy surfaces just with any scanner, it doesn't really work well. Baby powder, yeah, anything that is powdery, anything that is dusty, matte, and white preferably. So let's see, current triangles, 2.6 million. Wow, that's quite a few triangles. Can I cancel this and pick the low resolution instead? Because this might go for a while. Yeah, like that's just pegged. I should have went with the low resolution one, because again, it is. Look at this. It's 2.7 million points, which is an enormous amount of points for any 3D scan or for any 3D model. So yeah, just upgraded to an i9. Well, good job throwing your cash out the money, out the window, money out the window. Can you feel that 200? It's probably going to be more than 200 megabytes for an STL. Off topic, how do the Samyang lenses perform versus stock? Samyang lenses are sweet. Best. I can absolutely recommend every single lens they have. They're awesome. Oh, by the way, for the guy who just bought the i9, AMD just released a 16 core for the exact same price. Oh, okay, now we're moving along. Okay, 55, something's happening. Yep, Threadripper, exactly. I did try this on my desktop CPU, which is an 8-core, an old 8-core Intel, and that was obviously a bit faster. Look at that gloss. Look at the look at the sheen. Which is an 8-core Intel plus a GTX 970, so that was quite a bit faster. Let's see, polygons 3.5 million. That is way too much. But just look at that. Look at that scan. That's like smooth as a baby's butt. Should we smooth it even more? No. Let's see, simplification ratios. So we're at 3.5 million polygons. Let's just go to 1. Or 5. Let's go to 5%. That should still be more than enough polygons. Can we rotate this? Oh yeah, we can. Look at that! And even the holes that were down here, they are patched. There's nothing to be seen. There's even the little fat rolls on the legs, and that is original to the model. Just wow, butt crack also fully existent. Cool. Again, just for comparison again, there is the original model. There we go. That's the model we just scanned, and that's the scan. So it looks like just a few details, like this ball down here isn't really as crisp as it could be. So it looks like there's a bit more noise in this part right here, and oh, don't disappear on me. And the hair could be a bit crisper. Ah, so this is the simplified mesh already. Okay, so we did lose a few details going down to 177,000 triangles, but I mean, this is, again, this is a 4-inch or 10 centimeter tall model. I'm happy with that. I think that's going to be sufficient for pretty much everything you're going to scan. Your ball feels a bit smoothed. What did you do to your balls? Wait, let's catch up on chat. Feels like an acetone bath. Yeah, so I mean, I'm happy with that. I'm happy with that. And I think we could even straight up print this. Maybe take it into Mesh Mixer, just slice off a tiny bit. But let's see. So we're going to save this. We're going to save the STL. So these are all the individual scan files. I don't think you can actually do anything with them. But yeah, scan, STL, save. Scaling, do we want to scale it up or down? No. Well, yes, let's scale it for 3D printing. So let's do 50% scale, and that is going to output the STL to the correct scaling ratio. Let me minimize some windows here. So let's actually take this into a slicer and print it. Or yeah, print it huge on the CR10. Give me a second. Scan. Okay. Here we go. So slick thrower open. We are using the default. Let's use the 0.15 optimal standard. Prusa PLA. We're going to use the Mark II with Z-hop. Print settings, infill. We don't need any infill. Let's go down to 5 parameters. 2. 5 top, 5 bottom. Brim we don't need, but we want the first layer to be a bit fatter. I did talk about this in the Patreon hangout just a while ago, but yeah, first layer height, let's do 0.2. That's fine. Okay. And then we grab our STL. Okay, around x-axis, so that is, what is that, 270? To what? 270. Nope, exactly wrong. 180. So let's actually just see if this slices, if this gives it a smooth enough bottom. The size of the output file, so this was at 5%, and that is 8.48 megabytes. Okay, so that's not a flat bottom. This is not a perfectly flat bottom, right? Come on, right here, so you can see where it's how to slick through her. You can see it's only touching down with this small corner, so we will need to take it into look at you. We will need to take it into Mesh Mixer. I hope I have that installed. I don't. Okay. Just a second. So Mesh Mixer, I guess this is one of the typical steps that you're going to do with. Well, actually, we could just take it into Netfair. We don't need BattleNet. No. There we go. We could just take it into Netfab. I think that's simple for this. We could also cut the model in Slick Through. Wait, you can cut models in Slick Through? What? How? Split. Cut. Hold on. I'm learning new things here. I've never done that. So it is slightly angled even. Hold on. If we let's see. So it is slightly tipped forward. That might just be the individual scans that let's misalign. Let's see if we do 2, that tips it the right way. Okay. So that we could do, or just slice it with slice a bit off in the z-axis. Let's do another 2 degrees. Set -C. Slicer doesn't really do -Z, I believe. So first layer, not quite perfect yet. Maybe just tip it back a tiny bit more. And X. Sink it into the build plate. Nah. Does Slicer or Slick Thread do that? I always thought it always pushes it up. Look at that. That's looking better. First layer. So you're saying if we say move, well, I'll probably have to turn off auto center parts. That's off. Okay. So you guys are saying if I say moo, I can't. Whatever. Let's try this cut thing. So Z at 1, and we disable the lower part. Let's just do 0.5. Why does this not slice? There we go. Perform cut. Wow. Okay, well, that works. Slicing now? Quick question, has it always been? Why are we so small even? I thought we did it at 50%, so 200. I thought, did I export this wrong? Probably exported it at 25%. Okay. Yeah, learn something new every day. I'm hoping you guys learned something as well. But there we go, perfect first layer, round as it gets. So this is at 50% scale. This is half scale. And I don't think we could even print any more detail than this. Let's just try this. Where did I put my Mark II? And while that's printing, of course, we can have some more, we can do some more scanning. That's gonna go right here. This, by the way, if you look at this bed and you go like, what did you do to that bed? Again, that is glue stick, that is magic goo and 3D lac, and just every possible adhesive you could smear on the bed is on this very bed. So please excuse this. I know it looks like crap. Printer scan the G-code. Go. Exporting G-code. So yeah, with a lot of detail on the surface, the G-codes you print are also going to end up with quite a bit of size. I mean, it is an 8 megabyte G-code, which is large, an 8 megabyte STL, which is large for any STL. And then of course you slice it into layers. Each layer is going to have all those tiny moves. You can set a resolution in Slick 3R that like simplifies it to a certain maximum resolution, but I don't think that's enabled. But you could do that if you want to shrink down your G-code. The printer might choke on it a bit. We'll have to see. We're exported. Let's see how large this G-code ends up. Scan the G-code. So that's a 4 megabyte G-code. That's not too bad. Probably just that this SD card is really slow. So let's try this. Plop the card in. Just need a power cord. Good thing there are a few floating around here. How long have you been streaming? An hour. Okay, it's been an hour from the unboxing, plus a lot of talking. That doesn't fit well, but it's been an hour, including a lot of talking, a lot of back and forth to get a print going, which 3.9, that's an old slicer version. Support? No support. No support. No support. An hour from start to finish. That is, I think that is good. Did I forget supports? No, I don't want to print supports. Again, I believe that is intentional. did kind of change up the start G-code just to realign the Z-axes. Hashtag pro tip. Yeah! So the wings back here, yeah, they're gonna droop down a tiny bit. Maybe the feet up front here as well. But other than that, we don't need support. This leg should come out fine. So that's okay. What are we missing? We are missing one crucial ingredient to any 3D print, and that is filament. So let's use this stuff. This is white Atom PLA, Atom 3D, not atomic filament, that's different. Just load that up. Yeah. What is the last time I cleaned my bed? A few days ago. Simplify 3D does align the part bottom with the bed. It might, but you have to keep in mind that these scan bottoms aren't perfectly flat. They're not like a perfect polygonal they're not a perfect flat polygon. They are rough, they are textured, so there's not just going to be one flat surface that it can stick to like NetFab does. NetFab has that auto line feature. So any automated lay flat features, I mean Cura has it too. They're just not going to work, I think. So let's see, auto calibration, that's all fine and dandy. That's going to be working. 3D printed in inox, stainless steel. Nope. All right. So this is why don't they use Octoprint? Because it's simpler to just plop SD cards back and forth for stuff that I'm doing on the fly right here. So that's printing. Yeah. So let's oh, cool. Yeah. Right, so this is printing. Cool, that's a bit over an hour, including entertainment for you guys. Nice, let's keep this going and let's scan some other stuff while we're at it. So I want to try out this. This is a an IKEA bracket again. It is somewhat glossy. It is PP polypropylene. We're just gonna hawk this camera for now. So very glossy, very smooth part, not a lot of features. And it's gonna be interesting. So this recycling logo back here, that's probably gonna pick up. And I just wanna see how well these thin details pick up. Or a question, should we scan this guy instead? We have another camera. Should we scan this guy instead or the snail housing? Let me know. Let me know. Scan a fidget spinner. I don't think I have one here. What's the print speed on the Prusa? That's just default. That's 100% default settings. How long will the print take? Probably an hour or so. I think probably not longer than that. I don't intend to be streaming that much longer. Bracket, IKEA part. Okay, got it. That's decided. So this filament is in my way. I'm gonna scan a dragon. I don't actually want to scan a 3D printed part today. Yeah. So we go to screen cap. No. There. So there's that. This is, so the way these projects work is you have your project file, which I think gets auto-saved after every scan cycle. So this thing is safe. This thing is 100%, you know, on my hard drive. So if I want to go back and remesh this, or I think I might even be able to add more scans to it, I can always do this. So this save button only exports the mesh. So let's do a new auto scan with turntable. Hold on, did I even have to go? Yeah. We're gonna do a new project and we're gonna go new folder, Einscan-SP, and we're doing the IKEA cover. Here, cover project. Okay, non-texture scan, apply it. This is bright, apply. Let's do just as a start. Let's do 12 and let's go. So this is scanning right. Oh, I don't think I want to move it into frame right now. I'm going to do that in a second. We're looking for an exact replica to dimensions of the part. Is that capable? Yes, it is. From what I've seen, this thing is exactly... what? This thing is very accurate when it comes to dimensions. Ooh. At least on what I've seen so far. So there seems to be some texturing right here that wasn't there originally. That might be some artifacting from the light, because I do have fluorescent lighting in here, which does slightly flicker. So if anything, we might want to switch it up to the what's it called? Referencing mode, where it references off of the build plate markers. So that is done. Let's see. This front surface. Oh, we're gonna have to see how well that exports. So this surface right here did not scan at all. Camera hotkeys still aren't working perfectly. Does the printer make vibrations? Yes, it does. That might be causing some issues with the print. 1 second. There we go. That might be causing some issues because you can see the light wobbling around. You can see the light just slightly bouncing up and down. So we might need to, yeah, actually quite significantly. We might just need to move the printer off frame real quick. Yeah, sorry, you're not going to be able to see what it does, but we are going to have a sturdier scan, because this just, yeah. What we're seeing here probably really is from the scanner slightly shaking around. And if you look at the light projection, which is similar to what the cameras are going to see, it's the same device after all. This is kind of sensitive. You can see the edge right there. This is kind of sensitive to any sort of vibration, so if this moves around at all, there you go. So I'm just slightly shaking the table right there. If that moves around at all, I think that will cause some issues with the scan. So can we actually trash this? Delete, cancel current scan, yes. Oh, I like how that disappears. So let's just retry that. Exact same positioning on the table. Let's just see if that scans any smoother. Is there angle adjustment? What do you mean? Scan it upright to get all sides. Yes. I will try to do that. I will try to add that. Ah, yes, that scan is looking better. So I guess one thing to note, don't bump the table or the scanner while it is doing its thing. The room light doesn't affect the scanner short to ground. It does. This room is, I'd call, fairly well lit. It is a video studio after all, but it doesn't seem to be causing that much of an issue with the scan right here. So you can see in the background there. Whereas, can you see that on the screen cap? Yeah, right there. That's the softbox, the large one, and right. But my lighting here does not seem to affect it. So That's the first one here. So there is a bit of a shadowing effect right here where it didn't line up. The other side is fine mostly. Okay, it's also not scanned. So if I stand it up like this, then those parts are not going to scan either. So let's just try it. Let's just see how this turns out. And let's add another scan on top. Yes, the frequency of the light. I think the camera has some sort of anti-flicker included. So the scanner's camera. I like that patterning. Looks nice. So what you might notice is that the rougher structured light, these, they don't look like they have a ton of contrast. They're just very very soft, very blurry. The finer ones, these do have that sharp detail, but the coarser ones don't, which is interesting. So yeah, bottom is not captured. Yes. So yeah, you can see a bit of shadowing right there. That just seems to be, if you look at the scan, you can see the same. It is missing a bit from the front right there. And this looks okay. Let's see if that aligns to the rest of the scan. It should, because it does have these features on the back. These should give it enough information to align. Let's see. How long will that print take roughly? Not longer than an hour. Fardman, you think it's rather expensive? I think it is quite affordable for what you're getting, because structured light usually is quite a bit more expensive than this. And okay, so this one is maybe not the best example. So these small features right here, they are disappearing. And we're not, it doesn't look like we're getting good alignment with this part. So we might need to powder this. We might need to make this a bit less glossy, because again, this is just a standard injection molded, part, which does have quite a bit of gloss to it. So not the ideal example for scanning. Lesson learned. Okay. Most expensive IKEA spare part. Yeah, I mean, if you can't buy them anymore, then why not scan and print it? So yeah, I don't think this this scan is gonna get any better in the heat of the moment right now. I'm gonna try to do a texture scan. Too much red. Yeah, that's already on the lowest brightness. So yeah. There's the spring. I'm just going to use that. Can I not delete the entire thing? Can. How do I select all of this? If we go into brightness, this is already at the very brightest setting. How do I. There we go. Can it. What was it? That's invert. Okay, so we do. There we go. Trash. Let's just do new project. Okay. Because we need to set it into colored scan anyways, right? That's going to be the snail housing. So texture scan, apply, restarting white balance. Yes. So do we have a white surface right here? Okay. Yes, we do. So this, come on. This surface right here, this is the backside of the calibration plate. This is white. It looks like a, yeah, maybe slightly grayish white. So we're just going to plop that on here. And I think the scanner, you can actually see the DOP flickering right there. I think the scanner is just going to turn red, blue, green, and give us give this software a reference. So let's just see what that does. Restarting. So that's off. There's the red. Oh, green. That looks like it's 100% overexposed. I'm hoping that turns up. Well, so our snail model, well, our snail sample, it's gonna be interesting to see what these colors turn out like. I mean, it is natural brown, reddish. I don't know. Somebody in the audience probably has better names for these colors, but it's very natural color tones, and it does have a bit of color in there. So just gonna be interesting to see how that turns out and how much texture we actually get, because I'm thinking we should get quite a lot of texture. Now this does bounce around, so I will need to get out the putty for this. Should illuminate the whole platform. It needs to go down quite far. Alright, let's just give this a quick coat. I have no idea if I'm ever going to be able to get this off again, but let's just try. A bit more back here maybe. Burnt sienna. Yeah, burnt sienna. You can always throw that in there. Burnt sienna. That's like the, if you want to sound smart with your colors. There you go. Should I turn this by hand? Probably not. So this is pretty much a perfectly matte white scan. Let's see. I wonder if you just messed up the calibration by moving it. I don't think so. It does. It is somewhat tolerant to misalignment, it feels like, because it does look for features. It does you know, look at the geometry of the part and aligns individual parts. So bit of tape on the turntable just in case it doesn't want to come off. Yeah, I should have put a piece of tape on the turntable beforehand. So let's just see. Bright, medium, dark. Let's see. So I'm thinking somewhere around here. Bit of red right there. Some medium, healthy medium. That should be good. So 12 scans. We don't have a lot of undercuts on this scan, so that should be okay. And let's go. And there you can see the red, green, and blue illumination it does for every perspective. And we do have a significant redshift on this, it looks like. There's a good amount of texture coming in along with it, but the colors are off. Model the dough into a snail. Eh. So obviously at this point it is a point cloud. That's what the scanner is creating. But it's working its way around quite well, and I mean the color scan does add quite a bit of time. I mean, right now it is doing the surface scan, the geometry scan, and now like it did the unilluminated, then the red, the green, and the black, blue. So it does add a bit of time to the scanning process. So if you don't need color, you probably shouldn't try to scan color. Why is this pink on the scale? Why is this pink in the scan? Yeah, it might just be the white balance that is slightly off, just because the, I don't know, didn't white balance correctly. I believe you can go in and slightly correct this. It's interesting, this side seems to be okay, and now we're at this pink hue. Is it me blocking light? I don't think so. If you spray painted the IKEA part matte black, would it work better? It would. So this guy that you can see in the background here. Matte black, probably not, but like a very light gray, I think, is pretty much the ideal color you could do. So, yeah, scanning my fingerprints on the shell. Yeah, so the very fine structure that is almost at like a fingerprint scale, yeah. Wow, Panasonic autofocus. Nope. Always let you down. I mean, 4K autofocus isn't great. So this very, very fine structure that you see on it right now, that is actually the individual pixels of the LED projector, of the DLP projector. This is not a pattern that is projecting intentionally, but like on this side you see that is the pixels from the scanner. So I think that would be the theoretical resolution that you can get out of these. Maybe. But the software might be doing some smart things because these pixels are still sharp, they are still crisp. Oh well, okay. So our scan looks a bit pinkish, bit on the pink side. So obviously in the back here there is nothing, yeah, there's nothing on the shell, so that's okay. But this looks okay. On the top it has the same, I don't want to say issue, but the same effect as other scanners. It just cannot see the top surfaces, so we would have to rotate this around and rescan it. But I think this is actually quite good. This is okay. You could take this surface into so let's mesh this watertight, low detail. So if you take this into Mesh Mixer or Mesh Lab or whatever you want to work on with this, you can like create an actual shell from this. You could, my hotkeys are so buggy. You could take this surface, just shell it out, so make an actual defined shell thickness on this guy and use that for whatever you want. So the top surface you can use, and then obviously the colors you can work with those. You can see the texture, the colors are way off. Again, that might just be the white balance that didn't come together quite perfectly. Will it not be confused by the putty when you rotate the part? Yes, it will be, probably. So, can you adjust the focal length of the projector and camera? No. You cannot, these are fixed. I can actually grab the Einscan-SE unit and show you what the lens and body etc. arrangement looks like. Again, for people asking about the price, the Einscan-SP, that is the one we're using right now, which is a bit faster, a bit... Ooh, no. 5, 2, 5. The Einscan-SE, which is a bit simpler, versus the Einscan-SP, the silver one. This is the Einscan-SE with the black body. This is $1,200 with the scanner, and you also get the rotating platform, etc. You don't get a tripod and you don't get any markers with it. But this is $1,200. This guy is $2,500 roughly. Amazon links are in the video description. So if you want to, I guess I have to point this way down in the video description if you want to check that out. So yeah, again, the SE is basically the same unit as what we have right here with the SP. If you're doing the freestanding on a tripod scanning mode, it is, looks like the white balance actually, I'll show you that in a second. If you do it freestanding on the tripod, it has a slightly smaller scan area. So the SE does 700 millimeters cubed just because I think the cameras aren't as good as the ones in here. So like if it's limited to 700 millimeters, 70 centimeters, how many feet are those? 2 1/3, 2 and some inches, 2 foot and something. This one does 4 foot, so 1200 millimeters, and does a better resolution and scans faster, etc., etc. But this one will do most of the things that this one does, like what we just did. It will, the SE, the cheaper one, will also do. 30 centimeters, 12 inches. Okay, want to see a scan of a hand or a face head. That would require assistance, which I do not have. You can scan people, you can scan heads. Hair sometimes is hard because it's just so fine usually. Unless you put a crap ton of gel in it, then it is going to scan. But hair, I'm told, is hard to scan. Unfortunately, I don't have anything to try that. I could scan the hairy lion. Actually, let's do scan the hairy lion. Actually, as I'm looking at this thing, this looks so realistic. It almost looks like a little snail coming out here. It's almost like oh well. Yeah, it's almost like a Jane and Snow. So yeah, hair and stuff supposedly doesn't scan well, so you can put a cap over hair. That might work. But let's have a look at how the snail scan model turned out. So this is the solid scan that it filled the holes. So down here it has a few auto-generated texture features. And this is at 5% of the maximum resolution that we're getting. So if you're looking at the polygons here, that is quite a bit coarser than what the original scan was. This is just trimmed down to be handleable, manageable for me. But surface so far looks good. It's all watertight, details are there, and again, this is a snail that was maybe 3 or 4 centimeters, so an inch large, which is okay. You can use dry shampoo if you want good results on hair. From Dave Miller, he is one of the engineers at Shiny 3D, the Einscan manufacturers. So that is a good suggestion. Again, white powdery stuff that will pick up well. Okay, you like the way those polygons look? I do as well. So it's nicely simplified, and even at 5% of the potential output resolution, you still get a lot of detail. Let's see, that was relatively fast. Let's see how the medium detail one looks. And again, the processing speed, this is a quad-core Intel processor, but it has like 50% load of everything else this laptop has to do. So I'm running OBS Studio, web browser, whatever. OBS already uses like 50% CPU. So this usually does go a bit faster. DIY 3D laser line scanner, I've thought about that, but I don't see the value in it because the laser line scanners are just bad. I'd consider them unusable even for simpler stuff. So not sure if there's any value in doing a DIY laser line scanner. Mesh lab to correct colors, yes, of course you can do that. Let's just see how quickly this finishes. Okay, it's doing something. Quick check. So that's the medium. So we did do low detail and then simplified that to 5% of the polygon count. Well, let's check out what medium detail does on 100%, because the 5% is post-processing. So we could do smooth or sharpen. Let's do neither. Let's do the stock scan, and immediately you can see there's quite a bit more detail. It's quite a bit sharper, and the sharpen is actually a 3D sharpen. So, ooh, look at that. Look at that. Shiny. So obviously what we're seeing here, these vertical lines, this is just the physical resolution of the scanner. I think if we were to do a few more scans, or to do scans at more than 12 positions, at more than 12 rotational positions, that this would get us more resolution and less of these lines. But again, I mean, this is quite good. This is quite good to say the least. I mean, and again, for scale, that's the line. That's a snail right there. So it is a small scan, and we are getting a ton of detail from that. Why are the laser line scanners are bad? Yeah, they don't work. That's the problem. The laser line scanners, first of all, they have dimensional issues. If you can't calibrate them to an extent where they're perfect. The software for them isn't nearly as good as what we're getting here. The resolution is horrible, and even if you do get a good scan, it's going to have issues. So it's always going to take a ton of post-processing. It's slow. I don't think they're worth it. So yeah, this is like the minimum viable scanner, I'd say. Well, it's quite a bit better than the minimum viable scanner, but laser lines are just not a fan. So let's see what happens if we have like these finely textured hair. So this isn't exactly human hair. This isn't exactly like a fine human hair. I can put my head next to that so you can see the difference of maybe of how fine these are. But yeah, can you scan an M10 or M12 bolt in high resolution? Ooh, then print it to see if it works. That might be a good example. I do need to get a blackened one. I can't just scan a glossy galvanized one. Those are not going to scan well. But a dark one, or one that I quickly spray paint, that might work. Print is just barely past the ball, by the way. So yeah, let's give this a quick run, and I'm gonna hop next door to see what I can find bolt wise. So let's see. This snail, I'm happy with that. It looks like it kind of corrected the color after the fact, because this looks okay except for this part up here. But yeah, that's good. Silver bolt at hard to scan. Well, the hard to scan is only for bright or dark. That does not do glossy surfaces any better or worse than the regular scan mode. New project. Lion, I should give that the, let's call it SP line. So I mean that the software doesn't feel like a super snappy, super glossy, whatever, bright, medium, like a highly polished piece of kit. So that you can actually see the softbox in the background, so I'm gonna just slightly rotate that out of view. It doesn't feel like the most polished thing ever, but it certainly works and I don't see any issues with it. Do 16 positions and go while I grab a scannable item from the workshop next door. 42 patterns for each scan. It's a glossy in the description, really? Let's leave the microphone on. Yes, I know there might be audio cutouts. Deal with it. So I only have screw assortments up to M8 because I never use anything larger. But I might have a stray M10 bolt somewhere. I also don't have... Oh yeah, look at that. That's a fine pitch. What is this? It's a regular M8. Let's just try the M8. I am going to give it a quick coat with some spray paint. I'm sure there are some specialized I'm sure that there are some specialized paints or covers for this sort of stuff, but I don't have them. Let's see, bit of a hole there. Let's accept this. So the hair actually comes out. The hair actually comes out okay. So it seems to pick up the individual strands well. Maybe not perfectly. So there are none that are really the ones in the back here. Those don't seem to. Yeah, those don't look like they're being picked up all too well. So fine free-floating details like that, maybe don't do them. I'm sure if you add more scans to this, it would pick up more of this detail back here. But for now, that should just be enough of a visual representation. So let's give it a bit of a challenge. So we have this M8 bolt. Can you zoom in on the layer lines? Ooh, can we actually see layer lines? That is a good point. This is a wood-based filament originally, so layer lines are visually hard to see, and it also looks like there are no layer lines to be seen, at least not on the point cloud. We might be able to see some if we add more scans to this and mesh it, but right now I cannot see any layer lines right here. So challenge time. While the print is still going, I picked up this M8 bolt, which is an old, somewhat corroded galvanized finish. Yeah, kind of an old corroded galvanized yellow finish, but you can see it is somewhat glossy on the bottom here, so let's just try that out. Scan a benchy. Lots of undercuts. You're probably not going to get all that that detail. So let's see. Auto scan turntable. I mean, I will try. Is that infill line on the back? No. I will try the freestanding, the tripod scan mode for a full review. But for now, turntable only. Bolt. Non-texture scan. So, difficult to scan, such as dark, gloomy, shiny, or fuzzy. Yep, that sounds about right. And bright and dark, so HDR mode basically just takes a bright scan and a dark scan and fuses them into one. So let's just see, 16, yeah. Let's go, let's see what it scans. It might be somewhat bright for this. And I've also been told objects that have a regular pattern, like this hex shaft and then just a round threaded section on top, those might be hard to scan. But so far it is looking like it is picking up quite well. Can I scan my glasses? No, because I'm not going to be able to see if I take them off. All right. Looks like I'm missing a bit of the top section right here. It could just be because we have this bright background. Maybe let's take that out and see if that does any better. That's the calibration plate. Try scanning a phone. Okay. That's probably going to slide around. But the glossy front just isn't going to come out well. But we could try scanning the backside just to get a sense of how well like a phone case would work. So that did no, okay. That looks like a fun bolt to use, but yeah, that's not what we were scanning. So let's cancel that. Yes. Zip. And let's use the turntable coded targets. Make sure the scan is placed on the tripod and do not block the turntable. Yep, got it. So it's seeing the targets down here. Let's try that again. Because that turbine probably wasn't going to do anything. Phone case is going to work. Yes, very likely. Dimensional accuracy. So dimensional accuracy should be spot on. Again, this. Which camera can I show it on? This thing that we're printing right now. This little angel thingy. This, I know it is 101 millimeters tall, roughly. So it is quite good in the dimensional accuracy. It did scan at 101.6, I believe. Arduino is something that's small with SMD components. That could be worth a try. So one of the applications that I'm like thinking about is like doing. Do I want to use that? Nah. One of the applications I'm thinking about is maybe doing like graphics cards, coolers, etc. That you can just plop onto the scanner and 3D mill a surface out. And then just have it conform to all the components and anything on the PCB. So that might be a nice application. Scan the phone, then create the phone case for it and print it. Yeah, but not today. And I guess for that sort of application, having a... How many scans? Do we get a progress bar somewhere? Doesn't look like it. Or am I missing it? No. So for that sort of application, I do have a small Arduino. This is a MPU, ITG MPU, so an accelerometer PCB right here. I'm gonna plop that on and see how well that scans. Right, and that scan is looking much better. It is still missing the top somehow. So, and there's not a whole lot of detail right here, so let's just try and mesh this. Watertight middle detail. There's not going to be a whole lot of points to mesh, so that should be relatively quick. Okay, so as expected, a glossy, high detail M8 screw doesn't turn out all that well. I mean, I wasn't expecting this to scan well. But it's still nice to see like the threads coming out looking like threads. But again, I'm sure if we would have just taken some spray paint or something and quickly gave this thing a pass, because again, it is shiny, it is metal, it is galvanized steel, so it's zinc surface. This is shiny, which is not great to scan. So yeah. And again, I'm not even sure if the bolt didn't like have details like that. There is some dirt in there, but yeah, the threads aren't that dirty. So okay. Yep, print is coming out well. Let's do one more. Let's try this this little Arduino add-on board. Again, it is glossy, so I'm not quite sure how well that's going to come out, especially if you lay it flat. So surfaces that are flat like this apparently don't scan well, because the light is hitting it at quite a steep angle. So anything that is reflective and steep like that might not scan well, but let's just Let's just try it. So we can go straight into new project from this. So non-texture scan, apply. So it's just this tiny thing right there. Dark, difficult to scan. You are getting a few glossy spots, so maybe, nah. Maybe try this. Stand it up with putty. The thing is, if you stand it up with putty, I'm not sure how well the auto alignment is going to work. So this might might actually be quite challenging to print it. The two cameras and in one axis you need more. Yes, you do. Well, so the scanner has two cameras right here. So it has the structured light projector in the center, and it has the two cameras on the outside. So each time it rotates into a new position, it gets two scans at the same time. So this does get rid of that issue of having those undercuts, like where the light shines in but the camera can't see in. So that is already better than some of the LED laser line scanners, but it's that's why it's doing the individual positions. That's why it's okay. How much are we even getting here? Okay, that's why it's doing the individual positions and assembling that. Let's get a few more perspectives. This doesn't look like we're getting all that much scanned. We might actually need to stand it up on a small pedestal to get it raised up. So it does, I think the scanner does have a, the scanner does have, I think, a auto bottom cutting feature. It needs to, because otherwise it will always scan the table along with the print. So I think it automatically removes like the bottom layer. If you look at this, it probably just removed way too much. So let's cancel that. Let's plop this back to 8 scans just to make it faster, and let's stand it up with some putty. This is like, what are you guys calling this? Silly putty? Almost? So stand it up on one corner. So I don't care about the backside too much. The backside is just flat. So I think I'm just going to stick it down like this. Because again, for me, for this application, like I only care about the surface and the rest is just simple geometry. Simple geometry. So yeah. And this I can cut in any software. I can cut this in Netfab, Mesh Mixer, whatever I want. I can take it in and cut it out, and even like add the bottom surface if I ever needed that. So let's scan again. 8 scans, that should be fairly quick. Sculpting things out of putty? Maybe. So if you're wondering about my speed at which I read chat, or at which point I see chat, it is exactly when it shows up in the video feed, that is when I saw it and can react to it. So yeah. Let's see how much we get out of this. Yes, this is the $2,400 scanner. It is quite a bit faster than the other one. In fact, it is twice as fast. Interesting. Interesting. So I'm thinking it is again the reflective surfaces that are throwing it off quite a bit here. So yeah. So it looks like the parts here came out okay, but the highly reflective PCB, again, this is this area right here, this is highly glossy. So you see that just doesn't work too well with structured light. What would you use the scanner for? Yeah, so my first project is going to be scanning my car dash. I drive an old Opel Astra, and it has a, you know, just a outside temperature and clock basically in the center where you'd usually have a sat nav if you really want to have like a 2005 era sat nav in there. I didn't. So that position I usually put my phone, but it slides around. So what I'm actually going to do as like the first bigger project with this is I'm going to drop my, well, not drop my phone in there. I want my phone to be held in there. So I'm going to take this scanner on the tripod mode. I'll try to move it around inside the car and just scan that nook. You know, I don't care about the LCD in the background, but I'm going to scan that nook and make a phone holder that fits in there, because it's like irregular geometry. Like the bottom is sloped and the sides are at a weird angle, the top is kind of weird. So I'm going to try to make an insert that I can just plop my phone into and have that fitting in there nicely. So while the print is going, let's try a few more things. Astra, not the F4G, it's the H. Caravan, so the big station wagon. It was cheap. It's not a good car, but it's cheap. So there we go. So that's on there with some putty just to hold it down, because on the screen it would be sliding around quite a bit. So let's try this again. This is black. I don't have any talcum powder or flour or anything like that, but I do have something in my mouth. So it's going to be interesting to see how well this black OnePlus 3T scans. Let's just see. So again, can we trash this? No, we've already... no, right click, alt click. Can delete something here. Yes. Does it delete the mesh? No, it does not. Okay, new scan. SP3T. Non-texture scan. Dark, difficult to scan. Let's see how that works out. Set it in 45 degrees. That's going to be hard with the putty, because the putty does slide around slightly. Is the print nearly done? Yes, the print is nearly done, in fact. I'm gonna grab it in a second. So, absolutely nothing's being picked up. Nothing. No, not a single one. Okay, let's see, brightness. Let's crank that all the way to, there we go. That looks better. So again, this is a matte black phone. Oh, that might actually be too bright. Is it? Yeah. So this is a matte black phone. Again, black doesn't scan well, and glossy surfaces don't scan well, and we have a bit of both. Oh, that didn't update in time. Okay. So again, something like talcum powder would probably help. But otherwise, yeah, maybe stick with parts that are brighter. So this is not being picked up at all. It's just nothing, absolutely nothing. And I can't even see, with my bare eyes, I cannot see any texture being projected onto this phone. I mean, you can try and take a look. If I put my hand here, you can see what's being projected. But on the phone, you don't see anything. You don't see any texture. So this is just something that does not work for this process. Yeah, and the software is just not picking up anything. So dark stuff you definitely have to coat with something. I should probably cancel the scan before I do some stuff here. So just for you guys, let's scan a Benchy. Because you were asking for it. 1 meter and above. What? Is the camera fixed? The camera is fixed on the built-in carrier plate, so I don't think there's any way of adjusting this up and down. You could probably heat it up and bend it, but this is fixed in place, so you can't really tilt it down or up at all. Let's grab a Benchy. Do we have one that looks nice in my Benchy pile? Where the hell my Benchies go? That doesn't look too well. But maybe we can see, maybe we can try and see how much of the printing artifacts get picked up. Oh, that's an average Benchy. Alright, let's try an average Benchy. This does slide around again. Do you want to cancel the current scan? Yes. This does slide around. So there is a bit of a rubber coating on the outside here. So this outside does have a rubber feel to it. This does as well, but the center portion it's almost like a sticker, so it does not have anything that keeps it from sliding around. Right here I'd be comfortable, but here it just slides around. So I'm gonna use the at least like a very thin strip of putty again. Thanks for the $5 super chat, Michael. Glad you're finding it informative, entertaining, whatever. So that goes here, and we will need to rotate this, like the inside of the cabin right here. That's not going to scan. Also the inside of this back area where it's like this trowel. It's not trowel. This pen on the back, basically. That does not. That's just not going to scan. But let's see. So brightness. Not even medium. This is a bright part. This is a bright white part that is slightly reflective. You can see it just slightly glistening right there, but it should scan, I think. Doing 8 scans. Let's go. There we go. Ooh, look at that. That is coming out quite nicely. Use a small stand for smaller objects. Yes. Turntable targets. So we are still on the turntable targets scan mode. Why is this? This is all overexposed. It looks like. That is interesting. So first of all, let's switch it back to turntable. Let's double check the brightness here. So we cannot we cannot make it any darker than this. So apparently this gets, either that didn't save. Let's just double check it. Apply. So we're switching back to turntable, so it does not need to see the markers. Okay, so it looks like it's better. It looks like it's not going into the full red overexposed mode again, so that might have been an issue right there. Do a 180 scan. That's gonna take a while. The print's gonna probably finish before a 180 scan finishes. All right, but that is, I guess that is the way to get the maximum resolution out of your scans. So it looks like we're getting a bit of wobble right there. That might be in the print. I'm questioning my print quality right now. But what you actually can see right here, these are, at least I think, there are some blobs on this bench here. I think up here is where we have some that are actually original to the model. So this looks good. That's a bit of putty poking out. So let's try and realign this. It would be interesting to know how the official way of aligning and positioning irregular shapes like this would be, if it's, you know, using putty on everything, putty, and then just trying to extend it up somehow, or if there is some other official way. Because many parts just don't support their own weight, so standing on its tail will do in a second. Cool, and that should get aligned to that. Tripod holder turns into hand holder, Larencio is asking. No, it does not. So the thing is, this scan takes time. So it takes 4 seconds per scan. I think the SE takes 8 seconds per scan. So you would need to hold the scan in the exact same position for those 4 or 8 seconds, which you cannot do as a handheld scan. The Pro does that, the Einscan Pro does that. These you actually have to keep standing still, including your subject that you're scanning. You have to keep standing still for that exact time frame. So that is one limitation of this structured light scanning. There is some artifacting. Oh no, you know what? That's actually the layers. This is a 3D printed part, so there are some layers going on there. What this is exactly, I don't know. But these layers here, these are just the layers on the actual part. 8 seconds per scan. I think that might be the SE. It takes 8 seconds. Phone more reference grid in a dark room, most likely, or very likely actually. So there's a 3D Benchy scan. So there are still a few dark areas like in here. Not quite sure how we could get to those. Probably with like just a really fine scan. But what I'm liking is that there is no stray geometry. Like all the geometry you're seeing, except for these parts where you can see the putty, all the geometry you're seeing is actual geometry of the part. Like the laser line scanners, they are very easy to just add more and more geometry where it thinks it added or it saw something. This one, it rather leaves holes, which, you know, you can fill those in with more scans. But if you have geometry that just plops up all over the place, that would, you know, be much harder to work out. So yeah, with a few more scans, I think just standing upright or maybe laying down on the side so we get these holes filled in, we could complete this. But again, you can see this is a shiny white, so again, it's not perfect, but it sure scans well. You can see the layer lines here, and this is like 0.2 or 0.15 millimeter layers even. So it certainly does have quite a bit of resolution. How does scan with 180 steps look like? I don't know, probably better. I might need to scan something with that sort of detail, but it's not going to be today. That's just going to take way too long. Okay, so if we mesh this, watertight, let's do medium detail because the scan doesn't have that much detail to process. Is the print done? I'd love to show you, but that is quite laggy. Yeah. Again, CPU is at 100%, so please excuse that. It is at the face, so it should be done in less than 5 minutes. So both the SE and the SP do come with this table. So just let me get you a reference. So you get the same bracket that goes on the scanner. You get the same arm, just in black, and you also get a turntable. So that's the SEs. That's the Elite. That's the Elite's turntable, and that's the SP. So the premium. I never know which one is which, but the P, the silver one, that's the more expensive one. The SE, the Elite, is the cheaper one, if I'm not completely off here. You can see that the SP does have the targets on the platform, so if you want to align your rotating scans with those targets, using those targets, you can do that on the SP, but not on the SE. The SE just relies on exact rotations and on the geometry itself. So yeah, Marcin P. Again, if you compare it to what other scanners cost, I don't know. Can someone look up what the MakerBot digitizer costs? I think that's like $700 or something. So for just 50% more, you get a scanner that actually scans and doesn't just create some random blobs. Again, so I do like the fact that the software is so smart about just assembling individual scans. So you can just you can pull off your part reoriented and scan again, and it's going to align it automatically to your previous scans. I like that a lot. That makes scanning like intricate parts like this bench here that has a few areas that you can't really get to. That makes it a lot easier. Okay, so let's do 20. And scan quality is pretty good. Like sometimes with this glossy stuff and with intricate details, again, we should have added a lot more scans to this to fill in all these areas. Scan quality is really good. Like these steps right here, these are the 3D printed layers. These steps up here, they are the 3D printed layers that you see. These inaccuracies here, let me check. Yep, they're on the part as well. So you do get quite a good amount of detail and quite good detail reproduction on these scans. Again, this is just the areas that weren't scanned well, but with a few more scans we could fill those in. Digitize discontinued. Okay, yeah, that is definitely makes sense. 120 centimeters in tripod mode. Yes, that's the SP, and the SE does 700 millimeters in tripod mode. All right. Ow! Ah! Ow. Why have been my toenails? So this guy is basically done. Let's pull it up and have a look. So right there. Oh, and you know, speak of the devil. There it is. There's our 3D printed little scanned anciently thing. Cherub. we go. So let's put the original next to it. So this is a 50% print. There's the original. I think it's 50%. But I mean, detail is pretty good. Like, so what some of the cheaper, simpler scanners would always struggle with. So there's so much crap on this that yeah, parts don't come loose. But what the cheaper scanners always struggle with is like the inside of these wings. That's something that I've not seen scanned well yet. The inside of these wings are perfect. You can even see like the feather structures in there, and also the little belly area right there and under the arms. That was something that the cheaper scanners did not cover. Also under the legs, etc., etc. And that is all there. There is a bit of that is genuine. That is original to the part. So I'm thinking about the area between the wings here. Let's take this printer off. So the area between the wings, there is this there is this area right here, and it does have the original texture. There is this bridge between the wings right there. So geometry wise, this is as close as perfect as it gets. No butt crack though. Well, come on. There's most definitely a scanned butt crack on this thing. There's the original. There's the copy. It's there. It's there. It's scanned well. You see every detail. And yeah, I am happy. I'm happy with this. If only I had broken the printed part. But yeah, so far so good. I mean, for $1,200, that's pretty good. Let's take a quick peek at the Benchy again. I mean, lots of detail there, and even the other scans. So just for comparison, the what was it? Einscan-SP chair. There we go. Let's open that up again. Ooh, that's all the individual scans. So it didn't capture a few areas down here, but it got a lot of detail, got a huge amount of detail, and you know, stuff like the textures on the wings even came through, and that is pretty impressive, I think. So yeah, that is where we're gonna leave it at for today. Whitbox Go is $700. Yeah, I'm not gonna comment on BQ products, but I'm happy. So to be honest, I was expecting worse. From what I've read so far about the Einscan series of scanners, I was expecting a software that was borderline unusable. That was what I expected, and from my past experiences with affordable budget Chinese hardware and software, it might have come true. But the software is very usable. So I've heard reports of it crashing. I've not had it crash yet. It's not the fastest stuff, but then again, you're dealing with a huge amount of data. Scan quality is awesome. Scan speed, at least on the SP, is pretty good. The SE is a bit slow. It takes twice as long for everything, but pretty nice. Two cameras. Yes, I can hold this up again if I don't break the cables. Again, so the way this thing works is it has one structured light projector in the center, right there. Then it has one camera on each side. So just to show that again, that's what it looks like. It does not have like an infrared grid projector or anything like the Kinect does. So this is a visible light LED projector, and then the two black and white cameras on the outside. And that seems to be enough to get really good scan results. So yeah, thumbprint pressed into fine clay. You just want to get my fingerprints to like make fake fingerprints. Don't do that. pretty happy. Again, the SE is 1,200-ish bucks. The SP is 2,400-ish bucks, depending on where you buy it. Pretty nice, pretty good. Scanned everything so far, except for glossy surfaces, which was expected. Yeah, I'll keep playing with these. I'll do some projects, and I think I'm going to be able to make some very good use of these. I will be looking into how dimensionally accurate the parts are. I am going to measure just some measuring tape or something, or a yardstick or something that I know the dimensions of. But so far it is pretty good. It is pretty spot on. And yeah, thank you for watching. Thank you for sticking around. And what else? If you want to buy one of these, check out the Amazon affiliate link in the video description. That's the Genius links that takes you to the correct Amazon store for your country. Then what else? Get subscribed. We are nearing 100k, and there is some stuff coming up for 100k. I just got confirmation on Hangouts that we will be doing some giveaway stuff of some nice 3D printers. Yeah, but I'm gonna be in the Alps when we cross 100k, so it's gonna be a while. It's gonna be 2 weeks. If you want to support what I'm doing here, check out Patreon as it plops up in the sidebar. Awesome. And get monthly Q&A hangouts, one-on-ones, whatever you want. And yeah, if you're looking for a 3D scanner, this one so far looks pretty juicy. Thank you for watching. Have a nice Sunday, and see you around. Stop streaming. Yes. Goodbye.